Hello. So, as you guys probably know, you generated a graph yesterday, and this is what the graph should have looked like. So, you got kinetic energy on the y, and here I've got, let me hide that, you got velocity on the x axis. And so, you'll notice that you have a nice little non-line here. In fact, if I were to run a linear fit through this, like that, it's a 0.97. Not terrible, but not good. It's very clearly curving upward here. And so to do that, we need to linearize this. To linearize this, check the image to your right. Or just do a simple Google search of linearization graphs. And there's a graph that looks just like this. And so what we need to do is find the graph that matches this, which is pretty simple. It's the one that curves up like this, and it tells us to plot y versus x squared. So what are my x values? Well, my x values is not my kinetic energy, it's my velocity values. So I'm going to make another graph, and I will then square all of the velocity values. Now, if you know how to do that in graphical, do it that way. It's a lot easier. If you don't know how to do it, just hand calculate. Take 0.1319 squared, so on and so forth, and then just plot all of those same kinetic energies versus the velocity squared values. And then you're going to write the equation. Now, one thing to remember when you plot a linearization graph, it's really important to consider the units and the variables now, because what we're going to do, this graph has kinetic energy in joules versus velocity in meters per second, and it's not a line. When you linearize it and you get a perfect line like that, it is not going to be kinetic energy versus velocity. It's going to be kinetic energy in joules versus velocity squared in units of meters squared over seconds squared. And that